More than half of all missions sent to Mars failed. Some exploded on launch pads. Some vanished in deep space. Some slammed into the alien crust at hypersonic speeds, shattered into thousands of burning pieces. For decades, Mars earned a terrifying reputation. It became known as the graveyard of spacecraft. Yet, humanity kept going. We built bigger rockets, bolder AI, and machines that defied the laws of physics. Because Mars was never just another planet in the night sky. It was the first world we ever dreamed of calling home. This is the epic story of how humanity conquered the Red Planet. In the 1960s, the space race was at its absolute peak. The United States and the Soviet Union hurled probe after probe toward the Red Planet. And one by one, Mars crushed them all. Between 1960 and 1971, the Soviet Union launched over a dozen spacecraft toward Mars. Almost all of them blew up in Earth orbit, failed during transit, or missed the planet entirely. In December 1971, the Soviet Mars 3 lander achieved the impossible. It survived atmospheric entry and touched down on the surface during a roaring global dust storm. It began transmitting the very first television picture from the surface of Mars. 14.5 seconds later, the signal died forever. Why was Mars so brutally difficult? Because Mars sits in a lethal sweet spot of orbital physics. Its atmosphere is just thick enough to generate blistering friction and turbulence during entry, but too thin to slow a heavy spacecraft down using parachutes alone. To land on Mars, a machine must slow down from 15,000 miles per hour to 0 in less than 7 minutes, with zero help from Earth. Mars became known as the ultimate wall, a cosmic graveyard waiting for its next victim. On July 15, 1965, America's Mariner 4 flew past Mars, sending back 22 grainy black and white photographs. They showed cratered, lifeless plains. The ancient dream of lush Martian canals was shattered overnight. Then came 1976. NASA launched the twin Viking missions, the most ambitious planetary lander project ever attempted. On July 20, 1976, Viking 1 descended onto Chryse Planitia. Its onboard computer executed entry, descent, and touchdown flawlessly. Minutes later, the primary camera began scanning the ground below its footpads, streaming line after line of data across 100 million miles of space. When the full image materialized on monitors at JPL, humanity stared in absolute shock. It was not a dark, alien abyss. It was an orange desert strewn with boulders under a pink, dust-choked sky. It looked eerily like the deserts of the American Southwest. Viking 1 and 2 operated on the surface for years, performing automated biological experiments to search for organic chemistry. While the results were inconclusive and sparked decades of debate, Viking proved something monumental. Humanity could reach out, touch the soil of another planet, and survive. For 20 years after Viking, the surface of Mars remained silent. Landers were stationary, trapped wherever they touched down. On July 4, 1997, NASA changed the paradigm forever. The Mars Pathfinder mission landed, bouncing safely across the plane, wrapped in giant protective airbags. From inside the lander rolled a vehicle no bigger than a microwave oven, Sojourner, humanity's first wheeled rover on an alien world. Sojourner traveled just 330 feet in its lifespan, but it unlocked the key to the Red Planet: mobility. Seven years later, in 2004, NASA dispatched two larger twin rovers, Spirit and Opportunity. Designed to survive for just 90 days, these solar-powered explorers were tasked with finding geological proof that liquid water once flowed on Mars. They didn't just meet their goal, they blew humanity's expectations to pieces. When Spirit got stuck in deep sand in 2009, it turned its dead wheel into an asset, scraping open the topsoil to reveal pure, bright white silica, conclusive proof of ancient hot springs. And then, there was Opportunity. Opportunity roamed the plains of Meridiani Planum for 14 years, traveling 28 miles, surviving savage dust storms, freezing winters, and failing joints. In 2018, a catastrophic, planet-encircling dust storm blotted out the sun for months. On June 10, 2018, as its solar panels fell pitch black, Opportunity transmitted its final, heartbreaking telemetry to Earth. My battery is low, and it's getting dark. Opportunity died, but it left behind a legacy that transformed Mars from an alien rock into a place of human affection. By 2012, NASA was ready to go big. Really big. Solar panels were too vulnerable to dust. Small wheels got stuck too easily. NASA needed a mobile science fortress. On August 6, 2012, the Curiosity rover reached Mars. Weighing nearly 1 ton and powered by a plutonium nuclear generator, Curiosity was too heavy for airbags or conventional thrusters. Engineers at JPL invented a landing mechanism so insane that many inside NASA thought it was impossible: the sky crane. During 7 minutes of terror, a rocket-powered descent stage hovered 50 feet above the ground, lowering the giant rover down on nylon tethers before cutting the cables and blasting away. The sky crane worked flawlessly. Curiosity landed inside Gale Crater, a massive ancient impact basin featuring a 3-mile-high mountain of layered sediment at its center. Equipped with a high-powered laser, a robotic drill, and on-board chemical laboratories, Curiosity drilled into ancient Martian mudstones. It made a breathtaking discovery. Ancient Gale Crater was once a long-lived, drinkable freshwater lake system, rich in carbon, sulfur, nitrogen, and complex organic molecules. Curiosity proved that ancient Mars wasn't just wet. It was fully habitable for microbial life. Even with nuclear-powered rovers crawling across crater floors, engineers faced a physical barrier. Rovers can only see what is directly in front of their bumper. Steep cliffs, loose sand fields, and rocky labyrinth canyons remain entirely unreachable. To explore Mars faster, we needed to leave the ground. There was only one problem. On Earth, flying a helicopter is simple because our air is dense. On Mars, the atmosphere at the surface is less than 1% as dense as Earth's, equivalent to an altitude of 100,000 feet above sea level. No helicopter on Earth had ever flown that high. Many experts claimed a rotorcraft on Mars was mathematically impossible. To generate lift in air that thin, the blades would have to spin so fast they would shatter from centrifugal forces. NASA built Ingenuity anyway. A tiny 4-pound tissue box-sized drone equipped with 2 counter-rotating carbon fiber blades spinning at an astonishing 2,400 revolutions per minute, 5 times faster than a commercial helicopter. On April 19, 2021, strapped beneath the belly of the Perseverance rover, Ingenuity spun its blades, lifted 10 feet into the cold Martian air, hovered, and landed safely. It was humanity's Wright brothers' moment on another world. Designed as a simple technology demonstration meant to fly just 5 times, Ingenuity flew 72 times over 3 years, soaring over jagged ridges, scouting scout routes for the rover, and logging over 2 hours of flight time. Ingenuity shattered the myth of the impossible. It proved that human flight is not bound to planet Earth. On February 18, 2021, NASA's latest masterpiece touched down on Mars, the Perseverance rover. Targeting Jezero Crater, a site so hazardous that earlier missions were forbidden from landing there, Perseverance used real-time AI terrain navigation to dodge massive boulder fields during touchdown. Why take such an extreme risk on Jezero? Because 3.5 billion years ago, Jezero Crater was a massive deep lake fed by a roaring river. Satellite imagery revealed a perfectly preserved, fan-shaped river delta spilling into the basin. On Earth, river deltas are absolute gold mines for preserving biological fossils. Clay minerals trap organic matter, burying microbial signatures in mud for eons. Perseverance was built with a clear historic objective, not just to look for habitability, but to search for biosignatures, direct physical fossils of ancient alien life. Using a heavy rotary impact drill at the end of its robotic arm, Perseverance has been carving out chalk-sized core samples from the delta rock, sealing them inside ultra-pure, airtight titanium tubes and depositing them carefully on the ground. Perseverance is assembling a treasure chest of Mars' deepest secrets, waiting for the next great chapter in human exploration. The conquest of Mars is no longer a story told by a single nation. In May 2021, China made history when its Zhurong rover landed successfully on Utopia Planitia, making China the second nation to operate a vehicle on the surface of Mars. At the same time, the European Space Agency and India have inserted orbiters that track atmospheric methane and subsurface ice sheets. The global scientific community is now united around the most complex robotic mission ever conceived: Mars sample return. In a joint effort between NASA and ESA, a retrieval lander will launch to Mars, deploy a sample recovery helicopter, grab Perseverance's sealed titanium tubes, load them into a small rocket, and launch them into Mars orbit. An orbiter waiting above will capture the sample capsule in mid-space and sling it back to Earth. For the very first time in history, scientists in laboratories on Earth will hold actual pristine rock samples from Jezero Crater under electron microscopes, checking once and for all if we are alone in the cosmos. And behind the robotic probes, giant commercial rockets like SpaceX's Starship are testing massive heat shields and orbital refueling, building the hardware required to carry human boots to the red dust. 60 years ago, Mars was nothing more than a blurry red dot in a telescope, a cold, terrifying mystery that swallowed our early probes whole. Today, because of Mariner, Viking, Sojourner, Spirit, Opportunity, Curiosity, Ingenuity, and Perseverance, Mars is a world mapped in high definition. We have felt its wind, listened to its storms, tasted its ancient lakes, and flown through its thin sky. We did not conquer Mars with weapons or flags of domination. We conquered Mars through unyielding human curiosity, through engineers who refused to quit when their machines exploded, through scientists who spent their entire lives reading lines of code from 100 million miles away. Every rover track left in the red dust, every sealed sample tube waiting on the plane, is a testament to what our species can achieve when we push past our cradle. Mars was once the graveyard of our ambition. Today, it is the classroom where a planet-bound species learns how to become multiplanetary. And tomorrow, it will be home.